Another technique for solving quadratic equations is what's called completing the square. This method is best used when we run into a polynomial equation that does not factor, at least not one that we see obviously. Before I do that, I want to take you through a relationship about these 6 examples, all showing us what are called perfect square trinomials. They're perfect square trinomials because when they factor into a quantity, a binomial, squared. In each one of these cases, we get a binomial squared. The interesting relationship that we run into with each one of these is the following. In the first one, if you'll notice, if I take half of the middle term coefficient, that means half of the positive 4, that gives me a positive 2. If I take half of the negative 6, I find I get negative 3. If I take half of the 14, I get 7. If I take half of the negative 10, I get negative 5. If I take half of the 2, I get 1. And if I take half of negative 8, I get negative 4. Kind of an interesting phenomenon that happens with these perfect square trinomials, that when we look at their factors, that constant term on the inside is just half of that middle term. The other relationship you'll notice is if I take that now number that we have on the inside and I square it, notice I get the constant term of that trinomial. 2 squared is 4. Negative 3 squared, positive 9. 7 squared, 49. Negative 5 squared, 25. 1 squared, 1. Negative 4 squared is 16. That's going to become an interesting relationship that we're going to follow all the way through as we deal with this idea of what's called completing the square. All right, let's jump into a problem. Let's say I have a problem like this. I have x squared plus 12x plus 8 equals 0. And I want to solve this. Now I might try factoring this, and so I'm going to do the factoring and show you that in this particular case I run into a problem with trying to factor this. Using the factoring method that we learned in a previous video, I would do this. I'd concentrate on the x, which would give me an x and an x to get the x squared. Now I'd look at this number 8. How am I going to multiply two numbers to get to 8? Well, I've got a couple of options. I can use 1 and 8 and 2 and 4. The problem I run into with 1 and 8 and 2 and 4 is, in this case, both positive because I have to get a positive result. So I got to multiply by the same sign. And because our first sign is a positive, I know that these will be positive. But if I plug in a 2 and a 4, yeah, I get to 8. But my problem is, when I do that little smile, I get a 2x and I get a 4x. Well, that doesn't do me a lot of good because that only takes me as high as 6x. That doesn't get me to 12. If I replaced those with 8 and 1, and if you'll allow me, I'm just going to write right on top of this here. If I put an 8 here and I put a 1 here, it doesn't do me any good because that just gives me 8x and that gives me 1x, which gives me a 9x. Still does not get me to the 12. So in this particular case, this one doesn't factor. That's where our completing the square is going to come in handy for us, because that'll help us to be able to make it factorable. Okay, how do we do that? Well, we're going to do it in this manner. I don't like the 8 because that number's throwing me off for being able to factor this. So what I'm going to do is bump the 8 to the other side. I'm going to follow this simple process. I'm going to go x squared plus, I'm going to leave the 12x, but I'm going to put in the number that I want to make this factor for me. What am I going to do with the 8? Well, I'm just going to bump the 8 to the other side using our wrap method, which means it'll become a negative 8. But I need to make sure that I add the same thing to both sides. Now, I like to put the blanks in there so I remind myself that I have to add the same amount to both sides so I keep my equation balanced. Now when I look to factor it, looking back at those previous ones, I want to make this a perfect square one because that's the easiest way I know how to factor things. So using the examples from up above, this would give me an x. How do I find the number on the inside? Well, I take half of that 12. That's what the pattern was. Well, half of positive 12 is positive 6. So what do I do with that positive 6? Well, if I keep going with the pattern, it showed me that I take that number and I square it. Well, that gives me 36. So I'm going to be adding 36 to both sides. Very good. I add negative 8 and 36, I end up with 28. So far, it looks okay. At this point, we use that square root property, which simply says if I have something squared and I want to get rid of that, I'm just going to take the square root of both sides. So if I take the square root of this side and I take the square root of this side, whatever I do to one side, I do need to do to the other. On the left-hand side, the power drops off, so I'm left with just x plus 6 equals. And over here, remember we talked about in one of the earlier videos, whenever you take a square root, you're going to end up with a plus or a minus. And inside of this 28, I do have a perfect square. When I look at 28, that's the same as 4 times 7, 4 being a perfect square of 2, so I end up with an answer of 2 radical 7. Now I need to solve for my x, so I'm going to take that 6 and just move it over. And so my final answer ends up being x equals a negative 6 plus or minus 2 times the square root of 7. And what I end up with in this case are two irrational answers for me to look at and to use. Now, before I go farther with this, what I'd like to do is to prove to you that I got this right. This is a great method, but if I can't prove to you that it actually did give me the correct answers, that's kind of a foolish thing for me to do. So what I'm going to do, if you'll allow me, is I'm going to go back to the side over here, and I'm going to actually put this number in to that original problem and show you that we do in fact get the correct answer. So I'll write it out for us. It's x squared plus 12x plus 8 equals 0. And what I'm going to do is I'm going to take something squared plus 12 times that same something plus 8, and that's supposed to equal 0. What's the something that I'm going to stick in there? Well, I'm going to plug in there the negative 6 minus 2 radical 7. Negative 6 minus 2 radical 7. And I'm choosing to use this one. I could have used either of those two, but I'm going to choose this one. You could FOIL this out if you'd like to. I'm going to use kind of what we call a shortcut, where we square the first number, which would give me a positive 36. Multiply these two together, which would be a negative 12, and double it, and I get a positive 12 square root of 7, which would be a positive 24 when I double it. And square the last one, which is going to give me a negative 2 squared is a positive 4. The radical 7 squared is 7. 4 times 7 is a positive 28. In the next set, I have to use my distributive property, which will give me a negative 72. And it will give me a negative 24 radical 7. And then I have my plus 8, and hopefully this all will equal 0. Well, as I start looking at it closely, right here I've got a positive 24 radical 7. Here's a negative 24 radical 7. Those would cancel. When I look at adding the rest of this up, if I take the positive 8 and the 28 is 36, and the positive 36, that's a positive 72, all of that will cancel with my negative 72. So when it's all said and done, I do in fact get that 0 would equal to 0, and my problem checks out. So this method of completing the square took us to an answer, not necessarily a nice neat one like our integers were, but it does give us a nice irrational answer and shows us how we can solve problems like this even though they're unfactorable. All right. I would like to do one more example for you because I know that one worked out nice and neat for us. I'd like to throw one that's a little bit more challenging at us so you can see how we handle these types of problems as well. Okay. So our next example that we'll look at looks like this. What if we have one a little bit more complicated that goes 6x squared plus 5x minus 6 equals 0. You'll notice there's a couple problems with this one. One is I have a coefficient in front of the x squared. I haven't had anything like that up to this point. And the other thing you'll notice, this number's not even. Well, that's good. I want to make something a little bit more challenging for us. Here's how completing the square would work on this. The first thing is, we need to get our coefficient in front of the x squared to be a 1. To do that, we're just going to go through and divide everything by 6. I'm going to write it out. I know some people would take and just put the whole thing under 6 so they could see it. I like to do it this way so I can see that I've divided everything by 6. Now my problem will read this. X squared plus 5 6x minus 1 equals 0. And now I'm going to follow that method of completing the square that we did just above, which said this. It's the one that I'm not sure about. Now, for all I know, this could possibly factor, but I don't know, so I'm just going to take and bump that 1 over. That's the nice thing about completing the square. If I don't know how to factor very well, then this is a great method because I don't have to know how to factor, because this process will walk me through to my answer just following the process. Okay? Now, to make this so it factors really nice and clean for me, I'm going to continue that same thing, and I remember the relationship. I take half of this middle term. It's a fraction. Well, that's okay, because when I take half of that number, I end up with 1 times 5 is 5, and I get 2 times 6 is 12. I get 5/12. So what do I do with the 5/12? Well, I'm going to move that up here. But remember, that's 5/12 squared. Well, 5 times 5 is 25, so that'll be the top number. Leaving it in red so you can see where I get the number from. And the 12 squared is 144. That's the number that I'm adding to both sides. The 25 over 144. All right, well, remember on the other one, it added up nice and clean. I believe it added up to 28 when we looked at that previous example. Well, how do I deal with this? I have a 1 and I've got a fraction right here. Well, that's okay. I'm going to take that 1 and rewrite it in terms of a fraction. Since 144 is my denominator, I'm going to rewrite this as 144, and I like to do it right over the top of it so I don't have to mess too much. Over 144. 144 over 144, that's the same as 1. Now I can add those two numbers together because they have a common denominator of 144. And 144 plus 25 is 169. Give myself a little space. Here's what's really great about completing the square. When I take the square root of both sides, and you might say, uh-oh, we've got a huge problem now. Not as big a problem as you might think. This side gives us the x plus 5/12. The one thing I know will always happen on completing the square is this denominator will always, 100% of the time, turn out to be the same as the denominator I have here. In fact, if I take the square root of 144, I do in fact get the number 12. Remember, this is going to be plus or minus. Now, the top number I can't always guarantee. You saw in our previous example that it turned out to be the square root of 28, which wasn't perfect. But in this case, I get the square root of 169, which is, it turns out to be 13. So now when I continue with this, I would wrap over the 5/12. So even though I'm working with fractions, they're really taking care of themselves quite nicely. I end up with a -5. And I'm going to write it -5. I got the plus or the minus 13. And I'm going to put all of that over 12 since I have a common denominator. And now to clean up my answer, I'll just carry this out and simplify. -5 minus 13 over 12 would be a -18 over 12. The other answer, -5 plus 13 would be +8 over 12. Of course, we couldn't leave those two answers because we would be expected to simplify. We can divide, in this case, we can divide both of these by 3, so we can get, by 6, so we can get 3 over 2, so this is a -3/2. And this one, we can divide both top and bottom by 4, in which place we can get 2 over 3. So my solutions are these two rational numbers, -3/2 and 2/3. So that's the method for completing the square.